So open the exercise number 5. Okay. Open the exercise number 5, GE binary. That R script you just open. You don't open the R script. Now here we are going to do 2 steps, wide to long, because the cholesterol binary data is it in the wide format. You are going to do wide to long format, then GE binary analysis we are going to do. There are two ways to use two ways to transfer the wide to long format. I have given one format only in your sheet. Okay. So generally the SPSS file for in our Heaven package we will use to import the data set. This tidyOR is why we are using this package. To reshape your data structure, you are using this one. So this package is very important. And GE is GE package. Okay. It's overwritten 2 times. Now I have just import your wide data set using import function. Using import function, import function, I will tell you. SPSS from SPSS, browse cholesterol binary, B wide, cholesterol B wide. You have to choose the file SPSS cholesterol underscore B wide. That is your wide data set format. Okay. Now open it. Import. So now we are imported our data set. See, now we have body fat index value 4, 5, 6 times, smoking status, and cholesterol gender 1, 2, cholesterol status 0, 1. It's coded as a binary. Previously it has continuous code. Now you can see it's a binary. Now we have multiple variables, right? So now we are going to convert this wide data into long data. Pivot, the usual syntax only, pivot underscore longer. This is the function used to wide to long. And from what variable, what data? Cholesterol wide data. And columns, within this columns, whatever variable has the repeated measures, whatever variables has the repeated measures, those variable only we have to mention it here. The remaining variables, gender or whatever, the one-time variables, it will keep it as it is. Here no need to mention the variable which we need to keep it as it is. So only the changing variable, only the different time point variable only we need to mention it here. The remaining variable no need to mention in this syntax. But when you're using different function like reshape function, if you're using that, you need to give the keep these variables like that you need to give. But in this pivot longer function, no need to worry about the remaining constant variables. Okay. So this anchor, there are 2 ways to give this column. Matches within the double quotes, this anchor, the upper arrow symbol, and what are the variables? B fat. Before doing this, you just give names of your cholesterol wide, right? What are the name? Now see. So this is your variable's name in the data sheet. So I am taking B fat underscore 1 and all I am not considering. Okay. B fat only. Then smoking SMK and cholesterol COHL. and the recoded thing COHLR. Then we close the bracket and I'm giving the underscore. So all the underscore value I'm giving in the last. So I'm giving the variable which are repeating in a different time point. The character alone I'm giving within the bracket. Then end, just I'm giving the final underscore value and slash it. We are closing the thing. D plus means digit. One or more, how many time points? One time point or more time points? Two or three more time points. So add the number of time it has repeated. So here it's 6 times it's repeated. Here also 6. Here 6. So 6 times D plus means the digit plus plus plus. How many times it is repeated? So that is the D plus. And here names underscore 2 from this BFAT values you have to take, SMK values you have to take, cholesterol thing you have to take. Time is how many numbers after the underscore value. Okay, this is the one way of giving the mentioning the variables. The another way here, just start with in the morning wide to long format. You have one code, right? Wide to long format. In the thing I have given starts underscore with CF vector of just B fat underscore smoke underscore cholesterol, whatever the variable, you just give that variable and the similar pattern names underscore 2. And so there are different way of giving the measurement. So you just take a note of this one and that you explore it with. So run this code wide to long format. And you can see str of string of your data set, the character, everything. There is 882 rows into 8 variables, okay, columns. Again, we are importing this from SPSS, so I am defining as dot numeric, as dot fact, this kind of thing, okay. So these are the main effects we are running for a GE, but previously here we have given what distribution we provided for the linear Gaussian, because it's a normal distribution, but here it's a binomial, so binomial. So this is the model's result. One thing we are missing here, we are now just seeing the main effects only. So try to do with the interaction effect as your homework or whatever it is. You can try with the interaction effect, use the interaction effect for the body fat and smoking with time. Okay. Yeah. 1 second. It's a continuous, right? Zero one, it's a 2 level only. Okay, we can use it as that numeric as well as that factor. But
GG.
GG,
Like in the 43rd code,
okay,
GEEGLM, in that you are using the old variable names, but the new variable name is CH, capital, no? All caps.
oh, okay.
What is the purpose of, you are not using it in the model.
Okay. I will check 1 second. I have used new variable name only, right? SMK capital only, BFAT caps only. I have used new variable name only. Am I right? It's not smaller one. Here SMK is a smaller. I am given the new variable name only. Because I am assigning as dot numeric if any coded factor or any other format the data is considered means it won't show the result. So here I'm giving new variable name. You can give it same as small chol itself. You can do it in the same data itself. To for the convenient purpose, I just given dollar used different like capital chol, creating new variable. Okay. You can use it small chol dollar small ch means it will change the changes happened in the same data itself, the same variable itself. Okay. Am I answering your point? Or in that it's smaller. You just change it. Yeah, you just change it. It's a capital B fat and SMK. So this is the result. Now everything here it's in the coefficient format, but in the logistic regression, how we will provide the result in exponential format, right? So for that, I'm taking the coefficient and applying the exponential thing. So from the summary of GE model, I am taking the coefficient and extracting the standard error from it, and exponential, then coefficient of GE model, lower interval, upper interval, I am calling. What is the lower interval? Estimate minus plus or minus, what is 1.96 Z square? Yeah, into ZT, sorry, standard error. So this is the usual method to calculate the confidence interval. So I'm extracting, previously I'm extracting the coefficient from the model. Now only I'm applying the exponential function. Okay, previously I am extracting the coefficient, estimate and confidence interval for lower and upper limit. Now I'm applying the exponential for that. This is the exponential. So for this data, you need to do the interaction term, and tomorrow morning, if time permits, we can discuss that. Yes.